Good morning, everyone, and welcome to today's EnRoute webinar. My name is Bennett. I'll be the moderator for today. Our presenter is Aaron Clapp, Application Specialist at SAI. He knows everything there is to know about EnRoute, and today he'll be showing us how to apply toolpaths to 3D reliefs in EnRoute. After the presentation, we'll be able to answer any questions you have either about reliefs or any other EnRoute topics, so feel free to put those questions in the chat and we'll answer as many as we can. We are recording the webinar as always, so if you want to review anything that Aaron discusses, we'll be sending you all the link here this afternoon, so look out for that. And that's about it for me, so I'll turn it over to Aaron.
Okay, so we've been talking about reliefs and kind of, what to do with reliefs and how to add and subtract and do all that kind of stuff. And now we're coming to the tool pathing part. And there's a couple things that I want to say, some main things that I want to kind of show you guys in order to kind of more effectively tool path in 3D, simply because there's some things that you have to do first, and kind of getting that order is important. And then there will be some tips and tricks here that allow you to reduce your cut times and things like that. So hopefully this will be helpful in that regard. So I have some real basic shapes in here. And basically the things that we're going to talk about today are going to apply to, any kind of shape or 3D object, whether it be a texture or a sign or anything like that. So one of the things that we'll take a look at just right off the bat, the first thing is applying a generic toolpath. So in our top view here, you can see here that I've created two shapes. We've got a little bit of a dome shape here, and then we just have a flat relief that I have used this little profile for, and I used our handy little chamfer tool in order to create this chamfered little square. So let's start with the objects. And I'm going to be in this four perspective view for the most part, because I want to kind of show you some of the things that are happening when we're doing this. So in the front view, in the side, or in the right view, in both of these views, you see that when you create a tool or a 3D relief, typically everything you draw starts at 0, 0, or top of the plate. So, or top of the piece of material. And that's kind of just normal drawing in EnRoute. Everything is kind of at the top, or at 0, 0 by default. So when you add reliefs or you add textures or you start creating your 3D job, everything gets built up from the top of the plate up. So the first thing that you have to do is, once you're ready to toolpath, the last step right before going to toolpath is moving the material or moving the 3D relief into the material. And this is going to be important because otherwise EnRoute won't really know what to do with your toolpath. So, and again, this has to be your last step. So if you're going to make any other modifications to the relief, you need to do that before you do a path and before you move it into the plate. Because once you move it down into the plate, sometimes if you add reliefs or subtract reliefs, you can get some wonky things that happen just because it's expecting you to be starting from the top of the plate, because that's kind of where its reference point is. So that's just going to be really important. When you're modifying reliefs, so this kind of actually probably should have been something I mentioned on our last webinar, but when you're modifying reliefs, you always want to make sure that you're at the top of the plate like this and not below or not too far above it, because that reference point can skew things. So for example, if I were to try and use the chamfer tool, it could throw off your chamfer in terms of maybe it adds a bunch of extra space, or it inverts something, or it does something like that. So that's kind of one thing to remember. In this case, we're done editing. I'm not going to make any further changes. We're finished. I need to move this into the material. So the best way, or the easiest way to do that, is I'm going to highlight both of my objects. Well, in this case, I'm just going to highlight this one for now. We'll do something else with the other one. And I'm going to go to my surfaces menu. I'm going to say align reliefs, and then I've got a bunch of options here. Now, depending on what we want to do with this piece will depend on, what we want to, where we want to move it. So in this particular case, if we bring up our plate, we're cutting in 1-inch thick material. So that's kind of our base starting point here. And if I click on this object and I click on my F2 button, my precision input center says that this object is 0.75 and this one, let's see here. This one should be, okay, this one's 0.75 as well. Okay, so they're both at 3/4 of an inch. Great. So I'm going to grab this object, and because we have material that is thicker than the object that we're cutting, we're going to want to move it to the bottom of the material. So I'm going to say align reliefs to the bottom of the plate. So I click on that and it automatically moves this down into the bottom of the plate. This will mean that I need to cut off 1/4 inch of material at the top. So one of the things you can do to improve your cut times would be, in this particular case, if you could go with 3/4 inch material. That's basically what we would do there. That would actually eliminate the need for you to cut the surface, and all you need is cut the angles. So that's great. If we want to do it the other way, we could go align reliefs, and I guess I have to have something selected, otherwise that doesn't work. So align reliefs, and we can go to align to the top of the plate. There we go. So now, basically, I can accomplish the same thing here, and depending on what I want to do. Now, something to be aware of is that when I go to cut this, I'm going to have a little bit of a return, or basically a base to it. So I'm going to cut this angled piece, and then I'm going to have 1/4 of an inch of a base to it. If that's okay, great. Then you could just move it to the top of the plate. But if it's important that you not have that base at the bottom and that it be exactly the same size, you're probably going to want to move it to the bottom of the plate and cut off the top. Or if you don't want to cut off that top, then I would just go down to a material size that's exactly the size of the piece that you're doing. Sometimes that's not going to be possible because maybe your relief is not exactly 3/4 of an inch or whatever. So, that might also be a thing to consider. But in this particular case, we have those two options, and those are usually going to be the main options that you use. At this point, we are ready to toolpath. Now that it's into the material, now we can start applying our toolpaths. Typically, when we apply a toolpath to a 3D object, it's either going to be a hatch fill or an island fill or a spiral fill. EnRoute 7 has better spiral fills now, so they're not quite as inefficient as they used to be. But for this particular object, I believe that either an island fill or a hatch fill is going to work better, just because you can go back and forth quicker than if you go in a spiral in this particular case. Whereas the circle of the dome, the spiral fill would probably be more efficient for that. Let's just go with the hatch fill to keep it simple here. And then we're going to choose a ball end mill or some kind of an end mill that has a rounded tip to it. So I'm going to stick with a ball end mill because that's probably the most familiar ones that you'll use for this kind of thing. And then you can choose which one. Now, one thing to keep in mind is that depending on the detail inside of your relief will depend on the size of tool that you want to use. So in this particular case, this is a really simple, really basic relief. I could get away with using as a large a tool as possible, and this will make my cut go faster. Now, if I was doing like one of the bamboo textures or one of the wood textures, any of the other textures that have detail to them, I have to just keep in mind that the larger the tool, the more detail I'm going to lose unless I want to do multiple tools, which that is something you can do just like you normally would with EnRoute. I can go in here and say, well, I'm going to start with a 1/4 inch ball, and then I want to finish it with an 1/8 inch. and that might work out really well. So you can do that. The 1/4 inch will kind of hog out most of it, and then you can come back with your smaller tool. One of the other things to consider is when we add our tool, we want to calculate how deep we're going with our tool path. And I'm actually going to switch to our view here so we can see this a little bit better. So one thing to note about the depth when you're cutting an object is you need to know where is it in relationship to your material. So is it top of plate, bottom of plate? And then what's the thickness of that object? Well, we already know that this is 3/4 of an inch. So when we go into our toolpathing, we're going to assign this a depth of 3/4 of an inch. Now that may seem super obvious, but the depth doesn't tell it how deep it's going to cut necessarily. Think of it more in the parameters of this is how far it's going to look for a relief and then cut. So let's just apply a toolpath to this with a shallow depth of cut. So we'll go back with our 1/4 inch ball nose, and let's just say we do 0.5 inches. I'm just going to hit OK. We'll toolpath that real quick. I'm going to turn off my 3D relief so we can kind of see the toolpath. So what it's done is it's gone down. The software has looked. It's searching all the way down to 1/2 inch, and then applying a toolpath to that object up to 1/2 inch, and then it leaves the rest unfinished. So this is going to be more important once you are navigating different reliefs at different heights, top of plate, bottom of plate, things like that. So let's take this toolpath and let's delete it, and then let's move this all the way to the bottom of the plate. So now if I apply that same exact toolpath of 1/2 inch, now we're cutting even less. So what we want to do here is we need to calculate, okay, how deep is, or what is the thickness of our relief, and then how deep is that relief in relationship to the rest of our material. So in this particular case, if I was doing it like this and cutting the top and everything, I had set at the bottom of my material, I actually need to set this to 1 inch. So in my toolpath, instead of setting my depth to 0.75, which would be the depth of my relief, I need to add an additional 1/4 inch to cover this gap up here. So we're going to go 1 inch, apply, and that's going to cut. Now you will, for those of you who are savvy and have noticed, it still doesn't go all the way. Now, there's a reason for this, and this is going to perfectly segue into the next kind of thing to know about toolpathing with 3D objects. So we all know that when we toolpath a normal object, so I'm going to just draw a rectangle on screen here, something small. When I toolpath, say it's a hatch fill, this has no relief on it. It's just a square that I'm cutting with. We all know that it automatically offsets 1/2 the diameter of the bit so that the cut is actually the correct size. Because if it cut down the middle of your line, we all know that it would be too big or too small, depending on how the tool cut, or whether you're cutting on the inside or the outside, right? So that's fairly logical. Well, that same concept is happening here with our 3D relief. It's offsetting 1/2 of the diameter of the bit away from the edge because it doesn't want to go past that line. The software is designed to do that. So here's where our next tip, or kind of our thing to think about when you're doing 3D cutting is, okay, we need to change our toolpath just a little bit. So I'm going to say delete our toolpath. Let's start over. We're going to do hatch fill. And now, and you won't see this anywhere else, you won't see this in the normal hatch fill when you're just creating hog outs or pockets or anything like that. You're going to see this option for apply overcut. So when I check this box, the default is 0. What that does, this will push the toolpath right to the middle of that line. So let's just start with that. Hit OK. Now you'll notice as we zoom in, it's pushed the center of the toolpath right to the edge. Now you'll still notice that now we're getting closer to the bottom here of our material. In many cases, this might be enough. If you're using a smaller tool, this is probably fine. You're probably going to get away with that and you'll have no issues. But the larger tools, what basically happens, and I can kind of draw this in a visual form so you can kind of imagine what we're looking at. Imagine that this is your material, right? So this is that angle, and then this is the bottom of the material. And then let's just draw a circle to represent the tip of our ball end mill. And let's just imagine that we have, kind of just for our visual sake here. So imagine that this is an end mill and it's cruising along here doing our passes. One of the things that you'll notice is that as we get to the bottom here, the bigger the tool, the harder this is to get rid of this right here. So if we were half the diameter away from the edge, and that's approximate, there we go. So let's just say that this lines up with the edge, which it doesn't. So let's move it over just a little bit more. Okay, that's about good, right? That means that this little chunk of material right here is not going to get cut. So right in here, that's going to be left open. This is where the overcut applies. So when I say overcut, now it's going to push this tool, the center of the tool, right to the edge. Now you'll still notice that even though the center of the circle is right in the middle, we still have a tiny little bit of material that still is not cut. So we need to push it farther. So this is where you'll go above and beyond the 0 setting. So you can push it so that that tool will cut way out here instead. And now you have just like a tiny little bit. So, obviously at some point a round tool is not going to be able to cut in there. But at this point, it's so negligible. If you go back and use a smaller tool, you'll get rid of that. So what we can say now is, let's go back here. Let's go in here again. And let's say overcut amount. We're using a 1/4 inch ball end mill. So let's go, we could just say go 0.25 or 0.2 inches. Typically half the diameter would be, in fact, let's just do 0.125. That'll be half the diameter there. Click OK. And now you can see that this is the edge of our part and the toolpath is being passed beyond that. So now, as we look at the side view, now we're getting full coverage all the way down to the bottom. So this is something that's really important to think about when you're cutting stuff in 3D. Now, depending on the shape and how sharp your incline is, for example, in our rounded profile here, that's probably not going to be quite as big of a deal because we don't have quite so much of a steep upward profile. I'm probably going to have to say maybe we leave this at 0 when we cut this one. So you kind of play with it and just kind of see what works. And this is kind of something just to keep in mind. So that overcut value is going to be really, really important. So when we're cutting 3D objects, check the overcut. Typically, you never want to go more than half the diameter of the bit. That's just kind of a general rule. You can, but just know that typically half the diameter of the bit will typically do it if you decide to go that way. So that's something to keep in mind. All right, so let's delete that toolpath and let's talk about one of the other options, and that's going to be your fill. So if we go ahead and toolpath this as is with these settings, click OK, and I'm going to preview this in 3D here. Let's go ahead and go to machining, simulate 3D. That's okay. Okay. And this might be a little bit difficult to see. Yikes. It's going to be hard to see. Okay, you can see it right here. Perfect as a shadow. So here you can see that it's all the way cutting all the way down to the bottom material, which is great. That's what we want. But we've got these ridges. That is going to be something we're going to have to take care of. So let's hit done and let's go back. And let's reapply this toolpath. Delete. Reapply it. I'm going to go into my edit settings. And under here, there's going to be a new option for fill. And my overlap is at 50%. So 50% means that that's leaving kind of like a little bit of a wave pattern on my 3D. I'm going to want to reduce this or increase this, to a significant amount. So we're probably looking at, somewhere between 80 and 92% is typically your average for this kind of thing. That means it's going to create a lot more toolpaths, but let's say we do 88%. Click OK. Now we're getting a lot more toolpaths, but when we go to preview, we're going to get a much smoother result. Turn on that, let it process. And so now you can see we're getting a much better result. So now we don't have all those wavy undulations. Now, depending on the tool will depend on how much this you need to do. So smaller tools won't create this much of a big of a wavy pattern. So you probably don't need to go as high. Bigger tools you're gonna have to go higher on the overlap. So keep that in mind. That's going to be something you'll need to keep track of. So higher quality, smoother finish. You want to go higher on the overlap settings so that you don't get that little ridged look and then have to do a bunch of sanding, especially if you're doing it like on foam or hardwood. Hardwood specifically would be a bummer because then you've got, very difficult material to remove. Another thing that we talked about was adding 2 toolpaths. This is also something that you can do. Let's delete the toolpath and reapply it. And we'll go back to 50% on the fill so it's easier for us to see the different toolpaths here. But here's what you can do. So I'm gonna apply 2 tools. One is my 1/4 inch and one is my 1/8 inch. And on my 1/4 inch ball end mill, I'm going to say on my depth section, there's an option for step rough. If I click this option and then choose an offset, this basically what this does is it allows me to use the tool kind of as just a hogging out tool. So this would be actually a really good case to use our end mill. So instead of using a 1/4 inch ball end mill, I could use a fairly large tool. So maybe like a 1/2 inch end mill, give it a depth of 1, oops, not 10, 1, and go back here, finish it off with my 1/8 inch end mill. If I choose my step rough, then I can choose how far I want this tool to offset from the surface. Now, the reason why we have this setting is because an end mill is a square tool. So what this does is it allows you to say, okay, I want you to hog this out, but I want you still to leave, say, 0.0125 or some amount of material so that that tool doesn't actually accidentally nick the material as it's cutting its rough pass. Then you can come back and say, because I'm going to cut that, later when I do my finish pass. So I want my surface to be nice and smooth. I don't want to get any kind of tooling marks from my end mill. So I'm going to set a surface here. And this could be anything you want it to be. It could be greater, larger, or smaller. Let's just go with 0.025. And then we'll click OK. And then we're not going to do anything with the 1/8 inch end mill. Well, actually, here's what we're going to do. I want to increase my passes. So I'm going to have it do multiple passes. And this is going to get it a little bit closer to that, and then click OK. Now, if we look at it from the side view, what we have here is these are our passes for our end mill. So it's coming through, hogging out the top, getting to this level and hogging this out, and it's carving out all this material on the edge that doesn't need to be there. Then what that does is that allows you to use your 1/8 inch end mill for the parts that are actually necessary, because it's going to be a real slog if you try and cut this whole thing out with an 1/8 inch end mill, because you're going to have to do it in multiple passes and it would just take forever. This way, what you can do is you can say, okay, I'm going to do my 1/8 inch end mill in one pass because I've already removed all the other material, and the only amount of material that I have left is minimal. And so now I could just say, run my 1/8 inch end mill really fast, do the relief only, and then do then finish the part like that. So this is going to be a good way for you to kind of combine two tools to make the test go, or make the cut go faster. You could just cut it with one tool. That works too. But if you're wanting that fine detail, this is where using a step rough, hogging out all the material around it that's not necessary, and then coming back with your smaller end mill at a faster feed rate in one pass will help you do that. So that's going to be another kind of tip or trick to use in this case. Let's talk about one final thing when it comes to toolpathing 3D and using masking. So masking is going to be really important. So let's go back to, and I haven't used this round example because I guess I really don't think I need it, but let's delete the toolpath and let's just make this guy our focus. Let's see here. Where are we in terms of the material here? Okay, so we're at the bottom of the plate. Let's change our material thickness to 0.75. Let's do that. Hit OK. And then let's readjust this. So in this case, it doesn't matter whether I choose top of plate or bottom of plate. It's going to be in the middle anyway. So this is going to be representative of a really good scenario in terms of you're going to be cutting something and you already have the surface of your material cut. You don't need to cut all this top space. All this space up here is unnecessary to cut. It's just a waste of time. So it's pointless. You already have flat, especially if you're cutting out like MDF or something like that, sign foam. It's already perfectly flat. There's no point in going back and cutting this and just wasting a bunch of time. This could add hours, depending on your toolpathing, to your cut. So to remove that, we're going to use what we call a mask. And this is going to help us cut into only the edges of this profile. So the way we set that up is, oh, you know what? I'm going to close this file and reopen it because I actually need that little profile that I created this with. So, okay, perfect. I need that profile back. Okay, so I created this with this profile, right? And I told it to create the profile with the exact dimensions as this. So if I bring up my F2 menu, I can see that the width is 1 point, and I'm going to write this down, 1.5737. So that's how wide this profile is. Now, I don't need it to be quite that wide because there's a huge flat area up on here on top. So what I'm going to do is I'm actually going to measure, I'm going to break this apart actually. I'm going to explode, and all I want is the width of this line here. That's actually 0.7161. Okay, so from here to here is 0.7161. So that's all I want to cut. Maybe a little bit past it, maybe a little bit past it in this direction, but we'll kind of figure that out here. So that's my starting point. Now what I'm going to do is I'm going to grab my object here, and we're going to do what we call masking. Now, masking basically means I'm going to take an object or a contour. I'm going to mask my toolpaths to that contour. So for example, I'm going to just grab a square, draw it in the middle, and let's take our 3D off. And when I highlight both my relief and this contour and hit my toolpathing option, let's delete this tool here. Where did my toolpath go? Oh, you know what? I need to clear that as well because I did the step rough, so I don't want that in there anymore. Let's go back to a 1/4" end mill, 0.75, and let's just make sure our step rough is not turned on. It's not. Okay, good. Apply. All right. So now you can see that it's only applied the toolpath to this one section. So this is going to be the goal for us as we try and toolpath along the edge. So the way we do this is we can use our 3D relief to kind of accomplish this. I'm going to use my, let's see here, offset tool. I'm going to create an offset on the outside just because it's going to be visually easier for us to see. I'm going to say sharp corners. And what's half the diameter of our bit? We're going to use, let's just say we're going to use a 1/4" bit. So I'm going to do 0.125. That's great. Apply. I'm going to go back and select my relief again. And then grab that same tool. And this time I'm going to do an inline. Inline. Here we go. And this time I'm going to put in the value 0.7161, except for I'm going to add a little bit to it just so that I cover my bases just a little bit. So I'm going to say maybe 0.8. Whoops, 8. Apply and close. So now if we look at this, if we kind of turn on and off the relief, you'll see that the line is just past this guy, this ridge right here. So now that I have created my two reliefs, or my relief, sorry, not reliefs, my two contours, the outside one and the inside one, I'm going to go ahead and highlight everything. So I'm going to highlight both contours and the relief. I'm going to hit my hatch fill. I'm going to use this 1/4" end mill, just like I did before at 0.75, and click OK. And now we've created a toolpath that's only going to follow this little area. And of course, I have the overcut option. So let's actually remove that and try it again. I should remove the overcut because in this particular case, I'm applying an overcut with my contours, so I don't need to. So now I can push that toolpath right up to the edge here. Actually, in this case, I made a mistake. That's my fault again. So because I offset already, I do want to turn on the I do want to turn off the overlap. I just don't want it to be quite that excessive. So I want the overcut. I just want to leave it at 0. I've already built in the extra half an inch diameter, or the 0.125 on both sides. So now it pushes past on this side, which is what we want, and it pushes a little bit past on this side, which is what we want. So now when we go to cut this, and let's do this here. And the reason why I'm drawing this is just so that I can mask off my simulation. There's no point in simulating the entire thing. I click this option to mask off my simulation so that I don't process the whole panel. It's not necessary. And is it stuck? What has happened here? Where's my preview? Okay. Interesting. let's just change our tool. Not sure what happened there, not why it's doing that. Let's just grab our toolpath. Let's delete it. Let's just use an 1/8 inch tool just to make sure it's not. Let's see. We'll clear that one. 1/8, 0.75. Yeah, we'll do overcut. Try that again. Okay, so I must have something going on here with my piece. Oh, you know what? Okay, so I switched files and look at, so it's doing something. Okay, hey, this is a perfect example of what happens when you don't toolpath or you don't move your objects down to the plate. Okay, great. So now you know what happens. So it does weird stuff. So that is my fault because I had to switch the file. I remember now. So let's grab this, delete the toolpath, grab our 3D object and move it into the material. Now let's try this, and this should work. Oops, I think I might have over selected here. I don't need that one. I need just these two. There we go. Okay, perfect. Now this is going to work. Let's just simulate it. That is fine. Even if it's a small enough piece, it's going to be okay. So, in this case, it left a good amount of material up at the top here, and then only cut in this area down here. So now we don't need that extra cut. So now we've toolpathed along the edge here, and I think I still have something wrong with my toolpath. Oh, yes, because the material thickness is not correct, but that changed as well. But so it left this little tall spot up here. So, but that's the point, right? Is we have a mask now that allows us to effectively not cut the whole middle, which is unnecessary, and therefore saving us time. So, and this would probably be a good example to use the island fill, because it'll start and kind of go around the edge versus going back and forth. So those are a few things that we want to keep in mind when we're toolpathing in 3D. I know that's a lot of information to kind of throw at you all at once, but if you need to go back and review the video, remember, before you toolpath, so we'll just kind of recap real quick. Before you toolpath, make sure that your relief is inside the material, and then make sure and account for the depth of the material if there's extra. So in this case, my toolpath should be 1 inch deep versus 0.75, even though that's the thickness of my relief. So account for the depth. Use the step rough if you need to create multiple passes or multiple tools where you can rough out the material and then come back later with a smaller tool. Then lastly is use masks. If you can, and you don't need to cut a certain area, use a mask in order to filter out some of the nonsense that doesn't need to be cut and only cut the areas that are necessary. So using those masks is a key there as well. So hopefully that helps with 3D cutting. I know in the future we're going to be, I don't know that it's next month, but I think either June or July, we're actually going to be, I'm going to be designing and creating a 3D sign from scratch with the toolpathing and all that. So I'm going to get that set up, and then we're going to be doing that as well. So that'll be kind of in the pipeline for you guys if you're interested in that as well. We'll go from scratch. Basically, we'll start with nothing. We'll build it up. We're going to use layers and things like that. So I think we have an episode on layers in between there, so that you can kind of be aware of how to use layers before we get into it. Because once you get into advanced 3D, using layers and knowing how to use those is going to be really important. So we'll discuss that before getting into it. But one of the episodes, we're just going to go through a complete 3D sign from making it to toolpathing and that'll be a really good episode. So stay tuned for that one. But do we have any questions? I know I kind of ran a little bit long, but do you guys have any questions for me on this or anything in EnRoute related?
Yeah, get your questions in here in the chat, and we'll answer some here. We've got one from Gerald. He says, I'm just starting with trying to route 3D objects. What are the basic router bits to buy?
That's a good question. I don't have like a manufacturer necessarily that you can go to, but there's a lot of manufacturers out there. But typically 3D kind of stuff, you're going to be cutting with a ball end mill of some kind. So I would probably have a variety of ball end mills to cut with. One of the things that I will say though is in regards to your smaller ball end mills, get one that's tapered. They make tools that are tapered and they're a little bit more resilient. So basically they have this shape to them. So they're long and kind of skinny. And then at the bottom, they have like a tiny 1/8" bit. So those 1/8" bits are a little bit more resilient than others. And the reason why I say that is because obviously it gets thicker, the shaft gets thicker as it goes up, versus if you're talking like a tiny little 1/8" end mill, you've got a tool that looks like this. It's super narrow and super flexible. So what you can actually get is some deflection, or the other problem that a lot of people run in with these tools, they just break like really easily. So you almost have to just like, babysit them along. So if you're going to get an 1/8 or a 1/16 or a 3/32 inch tool to cut really fine stuff, I would consider getting one of these tapered 1/8" end mills that have a little ball at the end. They're a little more resilient, they're a little stronger. Yes, there are some circumstances where the edge of the tool might hit the profile. So that's where you're probably going to have the pros and cons. Maybe you have a few of the straight end mills like this, and then maybe you have a couple of these to kind of make up for that. But that would be one thing that I would recommend, just because those can break so easily. I know I've broken a ton of 1/16 inch end mills, and so they're just super fragile. So that would be one thing. And then in terms of your other, like your quarter, 3/16, all those are strong enough to handle pretty much anything for the most part. So you could just get a standard ball end mill and you'd be fine in terms of that. So I would just have a good variety of stuff so that when you have a need, you can say, well, I've got a variety of tools to kind of help me with that. But the ball end mill tools are going to be the ones that create those surfaces. Regular end mills can't create these 3D style surfaces. So that'll be just something to note. So.
Right. What other questions do we have for Aaron? While we wait here, I'll say that if you come up with a question, either when you're watching this back or if you just think of something later on, you can always add a comment to the YouTube video, the recording of this webinar, which you'll get later in the follow-up email to this webinar. But yeah, add a comment to that video and we can answer your questions there as well, or direct you somewhere where you can get the answers. Let's see, got another question here. Didn't catch how the custom profile was applied to the relief.
Okay, so I won't go into full detail on how that's done, but because if you actually go back to last month's webinar, we actually went over exactly how to use this profile with this tool. But I'll just kind of briefly show you which tool it is. So when you select your relief, you're going to use the chamfer tool, and I use the regular chamfer. So yeah, if you take a look at that last video that we did last month, we talked about 3D and some 3D tools, and we actually went over this chamfer tool specifically. So it'll be a really good one for you to kind of look over in order to apply that chamfer. And you can use any profile you want. So this is just one that I drew up real quick. If you have a DXF, so here's something that's kind of cool. If you have you've seen those custom router bits that you can buy for like a handheld router? Some companies will actually provide DXF files with the profile in a DXF form. So depending on the manufacturer, if you buy a tool from them or you see a tool from them, you can actually get a DXF or a PDF that has the profile already in a DXF form. And then you can import it into EnRoute, and then you can actually just use that to create your own 3D profile. And then use a ball and they'll cut it out. You don't even have to have that tool. So, that's something to consider too. Or you can just draw your own custom profiles and then create different kind of stuff like this. And this is really kind of useful for like doing shaker doors and stuff like that, cabinet doors. It kind of gives you a nice custom look if you wanted to do that sort of thing with 3D. So.
Gerald, in regards to your question, when will the next 3D toolpathing be? If you're talking about the webinar that Aaron talked about making a 3D sign from start to finish, that'll be in July 19th.
Yeah, I believe it's in one, I can't remember, but we have a couple episodes that kind of deal with some other things that are also kind of integral to that, like layers, like I mentioned. Because we're going to use layers a lot in that. So it's going to be really important to kind of know how to manage layers and kind of get around and what to do with layers. So we kind of wanted to hit on that before we did that so that you wouldn't be completely lost with what I'm doing with layers in order to handle that kind of a 3D type thing. So that'll be important as well before we head into that. But yeah, stay tuned for that one. That'll be a really good one.
Yeah, and then we also have past webinars and other videos on our YouTube channel that are about these topics as well that Aaron has done in the past. So you can always check those out if you're looking for more information on that. Tim says, is surface texture dropped into the plate in the same way as reliefs?
So that'll depend on how you decide to apply it, right? So if we take a look at this, and I'll have to move this piece back into the top of the material because we can't add reliefs without doing that. But so if you add a texture, you can either start from 0 or you can start from oops, that's not what I wanted to do. Let's go to all top view here. So, and we kind of talked a little bit about this in last month's webinar as well. But when you add a relief or when you add texture to something, so let's just say I wanted to add I don't know, a dots texture or something, right? I have several different options here. So I can add it to the existing relief. I can subtract it from the existing relief. I can merge it with the highest, I can merge it with the lowest, or I can completely replace the relief. So if I hit add, it's simply going to add it to my relief all over. And it kind of does this funny coloring. You can change that, but it's just to kind of help you differentiate. But so here what it's done is it's added these bumps to all surfaces. If I hit subtract, then it'll subtract it from the current relief. If I replace, then basically it's going to replace the relief in that area where that actually was. And so, that's something to kind of keep note of. And we talked about in the last video what effects each and every one of them have on an existing relief. That'll actually be really good to have you check that out. But yeah, each one of those has a different effect, and kind of depending on what you want to do will depend on what relief option you choose, whether add, subtract, replace, merge highest, merge lowest, that kind of thing.
Right. Got another question. What 3D format is ideal when importing organic objects to carve?
Probably STL. That's going to be your best option there. You can import them as a 3D DXF, but I found that it's better if you just choose OBJ. There's the Wavefront OBJ, which works okay, but I found that the best one is going to be your STL. It's the most industry standard format. It's probably the best one. It seems to have the best results. I would say STL, 100% if you can. If you can't, then I understand, but STL is probably the best.
Okay, got another question. If merged with lowest all neg space, would having the texture and reliefs emerge from the texture?
So it depends. In this particular case, I don't know that merge highest or lowest is going to do a whole lot, because of the way that this particular 3D object is. In that example that we did last week, we were combining two reliefs. And one of them was significantly lower than the other. In this particular case, I was just adding it to an existing relief. So I could try and see what it does real quick. I don't know that it's going to do what we think it's going to do. So let's just go in here and try our dots. And if we choose merge lowest, okay, so yeah, so not exactly what I would want, but basically it's taking the lowest point and merging that together, which if you're going to do that, again, the merge highest and the merge lowest are going to be the more complex ones to figure out and kind of use. And that's going to be typically used when you're combining multiple reliefs together that are significantly different in size. But so you kind of have to experiment a little bit with the merge highest and merge relief. But if you want more details, I would definitely check out last month's video on it, because it'll give you a very visual representation, because we did an example of each and every one, and what it does and what you can expect it to do. So that might be probably a good thing to check out if you're interested in that in more detail.
Okay, how would you create and import custom textures?
The textures that are here, in terms of these textures, they are currently fixed. You can take each one of these, though, and modify them to make all kinds of different stuff. So if I just go into like the flow, for example, I can come in here and I can change. I've got all kinds of settings. So I can change my meander size, the wavelength height, how much it twists, meander size, the power, the wave height. I can do all that kind of stuff. And each and every one of these textures has a huge variety to it. But I don't know it. Not that I know of it currently at the moment. I don't think there's a way to add any additional textures to the software. It's mainly the ones that we have here that are already pre-installed. But that's where, if you have a texture or a shape or an object that you like and that somebody has already put into an STL, then you can just import that 3D object and then convert it to a relief, and then you would have that.
Okay, I'm not seeing any more questions coming in. Thanks, Aaron, for answering those. I guess we'll go ahead and wrap it up for today. Thank you all for joining us for this EnRoute webinar. Our next EnRoute webinar will be about how to handle cutting a job larger than your table. That'll be on May 24th, and we hope to see you there. We'll have the link to sign up for that in the follow-up email that you'll receive later today. Make sure you're subscribed to our newsletter so you won't miss out on any webinars or other announcements. You can sign up for that on our website. Thanks again for being here. We hope you learned something, and we'll see you next time.